So for trimmed mean, here's my highlighter. What do you think of when you think of trimmed? Right, you're cutting up, right? So that's exactly what trimmed mean is going to do. Why do we trim things? Okay, to get rid of outliers. So the trimmed mean, here's the small one definition of it. We disregard an equal number of data points from both ends of the range. Okay, you cut from both sides. Trimmed mean, guys, trimmed mean for the most part is more representative of a measure of central tendency. Okay, omitting an equal number of values from the upper and the lower ends. Make sure you highlight that, make sure you know what we're talking about. Why would someone want to trim the mean? That's right, an outlier can skew your mean. So I always like, for example, the judging. Have you ever looked at, do you ever follow Olympics at all? Anybody watch the Olympics? I don't know, I'm not like following every sport during the Olympics, but if you do gymnastics or the diving, I love the diving competitions. I would never be able to do that. But there's always a score at the bottom, right? These are judges that give you a score from 1 to 10, right? Or something like that. I should probably check that out. But there could be a bias, right? Like if there's an American athlete performing and there's a Russian judge, there might be a bias to say like, whatever, I'm just going to give you a low score, right? Or there could be an American judge looking at that American athlete is like 10 out of 10, right? So to remove bias, right, to either side, we would just say, okay, look at these scores here. Well, let's get rid of the 10 and let's get rid of the 2, and just find the average score of whatever remains, okay? So then we're getting rid of any bias that may occur. So that's one of the reasons why you might want to use the trimmed mean. The other one is, for your tests, let's say you write 7 tests, actually 6 plus the 2 cumulative, so 8 assessments with me. And is it possible for you to have a bad day? Right? Maybe not. But it could be that you come for the test or you forgot it, right? It was a weekend, you were busy, you were working, you were focusing on a project, and you come in, you're like, oh shoot, today is a test. And so now it's going to be part of my record. But what if I said, well, let's get rid of that bias because something may have gone wrong. Let's get rid of that lowest score. But you can't just take away the lowest score. I must also take away the highest score, okay? Otherwise, it would be biased the other way. So you always have to take away the same amount on either end. And here's the good news. Some of these will make you guess. Some of these questions, like how many should I remove? 1 on each end, 2 on each end? The province will always tell you. It'll say, calculate the trimmed mean by removing 1 from each end, like the upper and the lower. Like, come on guys, that's a slam dunk, right? Like that is like, they're telling you what to do. You just have to make sure you do it, okay? So the trimmed mean, as you can tell here, if you had a bunch of scores, right, you would literally cut out the lowest and the highest. Is the trimmed mean always beneficial to you as a student? Is it always going to be the best way to go? No, it can actually bring your mark down sometimes, right? If you scored 100% on one of your tests, and let's say you scored a bit lower than you would like, sometimes when I trim, your mark actually goes down, okay? So you would have to calculate it and see, like, if you want to plea with me, it's like, please do the trimmed mean, Mr. Jurgensen. And I'm like, well, do the math first because it might actually backfire, okay? So that's what you need to be mindful of. Can I ask you to go to 30? I just want to give you a little walkthrough as to which one of the MCTs is mostly affected by it, okay? Have your calculators ready. on page 30. Okay, so determine the mean and median of the set below. Let's find the mean here real quick. If you add all of these up, you get 41.7 divided by 2, 4, 6, 8, 10. There's 10 values. The average is 4.17 units. We don't know what these numbers represent. So the average right now is 4.17 units. What is the median? If it's even, you gotta take 2, right? So there's 4 and 4, so the median is gonna be between these two values. So 2.3 plus 3.1 divided by 2. That is 2.7 units. Okay, so that's including everything. However, look at this, look at these values. Do you see the outlier there on the upper end? Right? What do you think that outlier is doing to the average? Think about it. Where is the outlier? It's on the right side. It's on the upper end. Guess what it's doing to the average? It's pulling it. It's literally, this one is literally pulling the average up. Okay? What do you think is going to happen if we take the same data set, but we say, let's trim 1 on either end? What do you think is going to happen to the average? If you remove 1 on each end, but you're getting rid of this higher outlier. What's going to happen to my average? Is it going to be less or is it going to be more? It's going to be less, yeah, because this upper outlier is not pulling it up, okay? So let's do the math here. It's still a mean, guys. It's still the average. And sometimes I go TM for trimmed mean, but it's still the average. How many values are left now? Instead of 10, I now have 8. Right? It should go down by 2. And here is where you can be clever. You got to be clever to save yourself some work. You can either add up the 8 that remain or take the 41.7 that I had for all 10 and I just subtract 0.7 and I subtract 20.2. Okay? And so my new total is 20.8. And what is that average? If you divide that by 8, 2.6. Has the average been affected by trimming it? Absolutely. It has been mostly affected. What about the median? Stays the same? What if these are gone? You now have 8 values, right? Your median is still going to be here between these two values because you've got 3 and 3. So yes, Gabriel already gave it away. No, it's good. If somebody's awake during my lessons, I'm thrilled, guys. I go home like party mode. Okay. The median has not been affected at all. The average has been affected a great deal. Okay. Do you think the median will ever change if you take away the same amount on either end? No, it's never going to end. I don't know where, I used to have a long piece of tape that I have since I started teaching. It's been getting shorter. I have to find it. I used to have a long piece of tape and I would fold it in half and trim, right? And then fold it back up and the middle is still where it used to be, right? It doesn't go anywhere. But it's been getting shorter, so I don't know, it's probably like this now. I probably kept it somewhere because I didn't want to lose it, so I think you get it. I think you get the point. The next exercise was to subtract, like trim 2 on either end. I'm not going to do this one because I think you get the point at this stage. The truth is this, guys. Once the outlier has been removed, trimming it more isn't really going to make a big difference anymore because the outlier is gone. Okay? So if you trim like upper 2, lower 2, or the upper 3, lower 3, it no longer really matters a whole lot. But can you remember this, that the mean is most affected by trimming the mean? By trimming the data. The mean is the most affected. Median is not affected. Will the mode ever be affected? It could be. It's very dependent on the situation. Because if your mode, let's say 20.2 is your mode because you've got two of them, if you trim and you just have a 20.2 left, all of a sudden your mode is either NA, not applicable, or it just flat out changes. Maybe some other number becomes the mode. So you got to watch out. But in general, mean is the most affected by trimming. Okay? All right, keep going. I will give you a little note here on 31. Just write it down, please. I'll try to keep it short and sweet. Recall, you need to know the arithmetic mean includes all values, because sometimes students forget that arithmetic mean is the average that you've been calculating since junior high, right? Arithmetic mean includes all values, even outliers. Outlier or outliers? The result may be skewed, biased. The trimmed mean the average calculated by removing an equal amount of values from each end. It is most right? The trimmed mean is most representative of information given by data. Okay, removes bias. And I will add this. Out of the MCTs, which is mean, median, mode, the mean is most affected by trimming data. Okay, so I'm going to ask you, knowing what you know now, I'm going to ask you to work through pages 33 to 36. But I will do one question with you so that you at least have this in your notes. So let's go to 32 and then do that one together. It won't take long. If you're still copying this, make sure you do that. Okay. What's the difference between a spider and the IT services, information technology services? A spider is happy to have a bug in its network. ICT would not like that, the IT services. Anyways, I thought it was funny. Calculate the arithmetic mean. It's just a regular mean, okay? So we're gonna add all of that up. 3 plus 9 plus 5 plus 8 plus 4 plus 6 plus 20. Divided by 2, 4, 6, 7. I said it too fast. Should have slowed down. If you add that all up, you get 55 divided by 7. You get 7.86, and we don't know what the units are, so it's okay to have decimals, no matter what. It's okay to have decimals. If it's people, cans, it doesn't matter. Sales. In statistics, it's okay. Identify outliers, any outliers, and calculate the trimmed mean. You know what? I'm going to do this. Let's do the outliers first. Out of all of these numbers, which one is the outlier? 20, yeah. Boom, we've got it figured out. And so now I will say remove high and low. Okay. So if we do this, maybe I'll do this one more time. I will arrange this real quick. 3, 4, 5, 6, 9, sorry, 6, 8, 9, 20, 2, 4, 6, 7. I've got 7 there. Remember, it's the highest and lowest. You don't have to arrange it, but it's easier to see. So you would get rid of the lowest and the highest. So your average now is 3 plus 5 plus 6 plus 8 plus 9. And then you just divide it by, instead of 7, what are you going to divide it by? 2, 4, 5, right? You're down to 5. That'll give you 32 over 5. (32) divided by 5 is 6.4 units. To be safe, let's go 6.40, okay? You'll never this can be done with temperatures. You'll see that you'll come across something called a Chinook. Anybody know what a Chinook is? In Calgary, if you go west, close to the Rockies, right? In Calgary, they have a phenomenon called a Chinook, which means it could be minus 20 or 30 in the winter, and all of a sudden overnight it goes to like plus 10 or 12. So you have snow when you go to sleep, everything is like freezing cold. All of a sudden the next day is like plus 10, 12, whatever, and most of the snow is melted. And that's because they're so close to the mountains, right? That air rises, it becomes warmer, and then it comes down the mountain into that city. Calgary is the one where you can see that effect most often. Would you want to say, hey, in the winter it's plus 12 in Calgary? Would you want to say that? would you want to use it as a selling feature? You'd probably be lying. It's biased. It's a rare occurrence. Okay, so that's where you want to trim your mean for sure. Okay, because you're skewing it. You're biased. Okay, so keep that in mind. Explain the difference between arithmetic mean and trimmed mean. You know what? In your own words, however you want to do it. You can just say includes all values. Even outliers. And this one removes highest and lowest. Why do we do that? Why do we trim? In order to remove the outliers. That's what we're doing. In order to remove outliers. That's why we are actually doing it. But some of those numbers are not outliers that you're taking out, right? But you're doing that to kind of even the playing field. Okay? So page 33 to 36. If you work, you should be able to do a couple, and you should be able to do an AC tomorrow on trimmed mean. Okay? I'll tell you this. Sometimes, unfortunately, the way I set it up, I don't tell you exactly how many to remove. Go by the outliers. If there are two really high numbers, guys, two really high numbers, there's two high outliers, then you want to remove 1 and 1, right? The highest and the lowest. And you technically want to then remove the second highest and the second lowest as well. You always want to do the same amount on both ends, no matter what you do, okay? So check the key if you're not sure. Ask me if you're not sure. But the province told us that they will always tell you how many to remove, which is like, wow, like why am I doing all this work, right? But you never know. They're sneaky sometimes.